Okay, now we're going to look at indirect proofs for the converse of the hinge theorem, which I call the side-side-side triangle inequality theorem. For this theorem, we're given AB is congruent to BC. We're also told that DE is congruent. AB and DE are congruent, BC and EF are congruent. And then the third sides, AC is bigger than DF. So we want to prove that angle B is bigger than angle E. And since we want to prove the opposite of this would be that it's not greater than. But we can't just prove it's not greater than. We have to take into account all possibilities of what not greater than means. So again, not greater than means that it could be equal to or it could be less than. So that's what we need to prove in this case. First of all, looking at B and E being equal, if these two angles are equal, then the two triangles are going to be equal by side angle side. And if the two triangles are equal, then AC and DF have to be equal. But we've been told that AC is bigger than DF, therefore that can't be true. And then we look at B and E having the relationship where B is less than E. If B is less than E, then we know that AC has to be less than DF because of the hinge theorem, the side angle side triangle inequality theorem. Since this came after it, we can use that whole idea. But if B is less than E and AC is less than DF, that contradicts that AC is bigger than DF. Therefore, both of these examples are false. That means that this is false, and so this has to be true. So that proves that this is true overall. So again, if B and E are congruent, are equal, then they're congruent. Then the two triangles are congruent by side angle side, and AC is equal to DF, but that's a contradiction. B and E being less than E means AC is less than DF, but we already know that AC is greater than DF. So in both cases, it's a contradiction because that's what's given to us. Therefore, this isn't true, and that is true. And then for this last part, the hinge theorem tells us that if two sides on one triangle are congruent to two sides on another triangle, and the angle in between the angle on one triangle is bigger than the angle on the second triangle, then the opposite sides have that same relationship where the first side is bigger than the second side. So we want to prove the opposite of that. Our conclusion is that the third side of the first triangle will be bigger than the third side of the second triangle. So the opposite of that would be that they're less than or equal to. So the third side of the first triangle will be less than or equal to the third side of the second triangle, and we have to break that up into two pieces. Case 1 would be where the third side equals the third side, and case 2 would be where the third side is less than the third side. And that's basically it. So again, the contradiction comes about by assuming that what we're trying to prove, we assume the opposite of that, and then we go and find a contradiction. And that's it for this one. Thank you.